So in this lesson, we're going to both interpret and create graphs that are based on real-world situations. You've probably seen a lot of graphs that occur in newspapers, magazines, on TV, anywhere in the news. We always have graphs that signify how something is changing. A graphical representation is great. So we're going to talk about interpreting that and even creating some of our own. So take a look at this graph. We're talking about how a swimming pool is leaking. So think about what's going on this graph. What do you think is happening as we go down this part here? We'll do that in a different color. As we go along this green part there, it looks like our water level is decreasing, it's going down. And then what do you think happens after 6 hours? Oh, maybe you stick a hose in the pool and you start filling it up. But you're fighting a losing battle there because you can fill it up, but then the water's just going to keep leaking out again. So let's talk about a few questions with this. First of all, what's its initial depth? How deep is the water to begin with? Well, that's our y-intercept. We see initial, we think y-intercept. So the y-intercept is at 2, so we'll say it's 2 feet at its initial depth. Maybe that's when we first noticed it. Well, then what's its depth after 6 hours? Well, let's read our graph. Let's go to where time is 6 hours. We'll go up until it strikes our graph. It looks like it's going to be 1 hour. After 1 hour, oops, not 1 hour, 1 foot. And then when's the pool at its greatest depth? Well, let's see, when is the y value, the depth, the highest? It looks like somewhere right around there. So I'm thinking at the 11-hour mark, maybe, is when the depth is at its greatest, and that would be 3 feet. So 11 hours after we started filling up the pool, and it's 3 feet deep at that point. So that's how we can read our graph. Now, something else that's good to know, and we're going to build on some of our domain and range concepts, is talking about the intervals of increase and the intervals of decrease. So over what interval of time is the water level increasing? When does the graph show an increasing rate? Well, it looks like it's at its lowest here at 6. And then it increases, we're going to say maybe up to about 11. So my green section is showing where it's increasing. So let's use that notation that we used, where we'll say from 6 hours, and maybe we'll use t in the middle. So as long as our time is between 6 and 11 hours, the level of the pool, the depth of the pool is increasing. And in a similar way, let's talk about the decrease. When is the water level decreasing? Well, my blue path shows where it's decreasing, but notice that's not the only spot. It is also decreasing once we shut that hose off, I guess. And it's going to go down to about there. So our intervals of decrease, it looks like from the start up until about 6 hours, that's when it's decreasing. And we have another interval as well. And this is going to be when our time is greater than or equal to 11 hours. We don't know how much longer we're going to go. We only have data up to the 16th hour. So that's about as far as we can go there. We can say that t is greater than 11, meaning from 11 hours and beyond. So check out those intervals of increase and decrease. I'm going to ask you now, take a look at this graph. Can you determine its intervals of increase and intervals of decrease? And write in that good interval notation that we use with the inequalities. So first, the interval of increase. It looks like in blue, the graph is increasing, the graph is increasing, the graph is increasing. It's increasing, and right about there is where it starts to decrease. So that looks like it's at about, is that about 4.5 hours? 4.5, I'm not even sure if there's a time on this. I'm not really told if there's a scenario. It's just reading a graph. So maybe we'll say then that it's between 0 and 4.5. That's when our x value, ooh, there's a little x here on the axis. And then over what interval is the graph decreasing? Well, we'll do that one in green. Once we hit this spot here, we're going down the hill. So that's going to be greater than 4.5. So as long as x is greater than or equal to 4.5, that's when our interval of decrease is occurring. So now let's go the other way. Let's take a story and make a graph out of it. So we have an air temperature. It's increasing steadily for several hours. Okay, so some key phrases there. It's increasing and steadily. Think about what steadily might mean. Probably going up at the same rate, a constant rate. Okay, so it's increasing, and then the air temperature remained constant. So we kind of level off our temperature. And then at the end of the day, the temperature increased slightly. So we get an increase in temperature, and then it drops sharply. That word sharply might imply that it's going down maybe quick or fast. So you tell me, what graph do you think models that data, models that description? Did you choose choice C? That would be pretty good. Because as I'm reading that, I'm thinking the temperature is increasing steadily. And then it remained constant. So notice that constant part of the graph. That graph is constant. We should say the temperature is constant. Because while time increases, as x increases, the temperature isn't going up or down. It's staying the same. So the temperature represents a horizontal line there. Then it increases slightly, so it goes up a little bit, and then it decreases sharply. Good graph there. Hopefully you chose choice C. Let's do one more together. Oh, I remember this question from a Regents exam. So this driver leaves home, and they drive at a constant speed of 60 miles per hour for 2 hours. Okay? They get a flat tire, and you spend 30 minutes changing the tire. How far have they gone in those 30 minutes? Then they keep on driving, and they drive 30 miles per hour for the remaining 1 hour. Maybe they put one of those little tiny spare tires on there until she reaches her destination. And we want to draw a graph that models the driver's distance from home. Okay, so that we're starting at home. So when you're at home and you get in the car, you've gone 0 so far. So the point 0, 0 is going to be on my graph. Now let's go through this in parts. A constant speed of 60 miles per hour for 2 hours. So 60 miles per hour for 2 hours. Notice my units cancel out here. 60 times 2 is 120 miles. So in those 2 hours, we've gone 120 miles. So that means that the point 2, 120 is going to be on my graph. After 2 hours, we've gone 120 miles. And let's think about what happens then. You get a flat tire and you spend 30 minutes changing the tire. So when you get that flat tire, has your distance from home changed? You stay in the same distance for now, but you go for another 30 minutes, you're changing that tire. So maybe that means 2.5, 120 is another point. I've gone 30 minutes, but again, my distance hasn't changed. And then I drive 30 miles per hour, and I do that for 1 more hour. So now I've gone an additional 30 miles, and it's taken me an hour to do it. So if I go another hour past 2.5 to 3.5 hours, I've gone 30 more miles. I'm 150 miles from home. So let's plot that point 3.5, 150. It looks like about this. So on the set of axes below, let's draw that graph. And again, notice that we talked on, highlighted in green a little bit. She's driving at a constant speed for the first 2 hours. So here's our constant speed. Then you get a flat tire. Well, your distance isn't doing anything. And then we're going to drive 30 miles an hour for the remaining hour. Let's make that assumption that we are driving at another constant speed. So this graph would represent the driver's distance at any time from home. So hopefully this lesson, you're able to learn how to read a graph for intervals of increase and decrease, write with those intervals down, and also maybe sketch a graph given a story.